All right, so the last theorem that we have to talk about in section 7.2 is the parallelogram diagonals theorem. And so this was the activity that I wanted you guys to do first before we actually looked at what the theorem is. So if you notice in that parallelogram, there are two sets of congruent triangles that are opposite of one another, thus making these two segments congruent to each other and these two segments congruent to each other. So since they're congruent to each other, that means they're the same length, which means that whole entire diagonal segment is bisected. So what this is saying is if it's a parallelogram, the intersection of those two diagonals bisect each other. So they cut each other exactly in half. So that's what we're going to look at, a few examples of this last theorem for this lesson. Alright, for number 6, we're going to go ahead and draw in the parallelogram LMNO with those vertices. Now, the question says find the coordinates of the intersection of the diagonals. So we need to find where those two diagonals cross one another. Now I'm going to go ahead and just sketch them in. Close enough. And we can see that they do in fact intersect, and it looks like they're going to intersect at 4, 2. I had to go by 2s in my graph because there wasn't enough room to fit it on there if I went by 1s. Now, in theory, if we do our math correctly, we could pick either one of the diagonals and just find the midpoint because a bisector is just the midpoint. So I am going to choose MO. Now, you could have chosen LN, doesn't matter, but I chose MO because, not because I'm lazy, but because I'm efficient, and O has the point 0, 0. So that's going to be easy for me to be able to find that midpoint. So the midpoint formula, we add our x's, so 7 plus 0, my two x values, and divide by 2. And then we add the y's, 4 plus 0, divide by 2. So 7 plus 0 is 7, divided by 2 is 3.5. 4 plus 0 is 4, divided by 2. 4 divided by 2 is 2. Now, looking at my sketch, I thought it was going to be at 4, 2. But actually, if I would have drawn a little bit more accurately, these two lines should cross one another at 3.5, 2. So I'll try to draw that in a little bit better. There we go. And we can see that they cross closer to 3.5. Now this next question is a little bit different. So instead of asking us where do the bisectors intersect one another, this question is asking us to find that fourth coordinate. And believe it or not, in years past, this was the most missed question on the Chapter 7 test. You might be thinking, now why is that? But you really have to be careful. So go ahead, pause this video, and I want you to plot those first 3 points. All right, so we have those 3 points. Now, it tells us the parallelogram is W, X, Y, Z. So I can go ahead and connect W and X. Then I don't have my Y. So that tells me my Y is going to be somewhere over here. I just got to figure out the exact location of it. And then down to Z and then back over to W. So I want you to think about, don't just listen to the video, pause it and think about where would that last point be. So pause it, think about it, try to make your approximation. All right, so maybe you thought about the slope or just how far apart 2 points are from one another. So one way to think about it, in the past, this is what students have told me, well, X to W is down 5 and to the right 2. So to get to Y, I would have to do the opposite. So I would go up 5 and left 2. So that means Y would be located right here at 2, 1. Or some people instead like to look at W and Z, seeing that you would go down 1 and to the right 5. And it has to have the same slope because if it's a parallelogram, the two sides have to be parallel. So from X, we got to go down 1, right 5. And check it out. It does not matter which of those methods you prefer because you're going to wind up with the exact same coordinates for Y. Either way, we get 2, 1. All right, this next slide just has 2 more examples that I would like you to try on your own. So I'm not going to put them up. I'm just going to put the answers up. So go ahead and pause and try these out for yourself. So I went ahead and drew in this parallelogram, but I want to make a point that you don't have to actually draw the parallelogram on the graph because Technically, all I need to know is I got to find the midpoint of the diagonal. So I'm going to look at this name of the parallelogram, and since T and V are opposite of each other, that means they're a diagonal. So I could just do the midpoint formula for T and V, or S and U, because those two are every other. So that means they're opposite of each other. So I could just do the midpoint formula for S and U. So I'm going to go ahead and just demonstrate that. Adding my x values would be -2 plus 6 divided by 2 for S. Here, I'll circle them. And U. And then my y values, 3 plus 3 divided by 2. Sure, you could have picked TV. It does not matter, because when we do it, either way, we wind up with 2, 3 as that point of intersection. Now, on the last one, when you plot those 3 points, that fourth point, which should be located between C and A, because it is point D, is located at the coordinate of 0, 1. All right, those are all of the theorems about properties of parallelograms, so you are now good to go ahead and do homework 7.2.